So let me explain how to prepare the Monday midterm examination. This is the final review for the incoming midterm examination. So look at our learning material. Homework 3 was uh, write Python code to find the greatest common divisor of A and B. And there are two possible methods. First one is by Euclidean method, and second one is just the coding method. Okay, and the Euclidean method is very important in discrete mathematics, and and also after the midterm examination, we will study the proof for the Euclidean algorithm. Euclidean algorithm is to find out the greatest common divisor. So this will be our final examination problem. So, okay, this will be uh, the proof for this kind of a mathematical statement is our final examination problem. So before that, in our incoming midterm examination, we will study the Python code for to represent Euclidean algorithm in Python language. Okay, so let's just go to the main point. So this will be exam problem. Okay, so first one is a coding method. Coding method is using the recursion. So this is the not recursion, but this one is uh, the Euclidean method. Okay, so this is the one. So you must memorize this one. So if you have two numbers, and then the Euclidean algorithm is, so if you have A and B, then the Y, one of them is zero. Until one of them is zero, then just repeat this procedure. So Y, uh, this one and this one, both A and B are not equal to zero, then continue this one. Okay, this process will stop if one of them is zero. Then if this one is stop, then just return AB and just print FAB. Then one of them will be zero. Okay, but the other one is greatest common division. So if so, the one of them will be zero. Okay, so uh, if A is greater than B, just replace A by the remainder. A is divided by B, and there will be a remainder. So A is replaced by this one. And else means if A is less than or equal to B, then just replace, in this case, just replace B uh, by this one, okay? And then after this process, if A and B are not equal to zero, then continue this process until one of them is zero. When one of them is zero, then stop the procedure and return the value A and B simultaneously. And then when you print out this value, then one of them will be zero, and the other one is the greatest common divisor. So, okay, this is the Euclidean method to find out the greatest common divisor. And there is a second method. So this is the second method. So, and in this case, write a Python code for the following output. So if you execute a Python code, then if you have this kind of output, then what is the possible Python code to generate this kind of output? Okay. So in this case, now A is 196, B is 168. Look at this. X is this is a list. A is this one is this is a set. Okay, set. And then look at X. X is there is number is ordered, but the set A, the 98 there, 4 is there. So uh, this one is not ordered because okay. So list is just one the small 2 and 4, 7, 14, so okay. So it's an increasing order. But look at A is a set. This is a set. And then 1, 2, 9, 8, 4. So there's 9, 8 there. So this is not an increasing order. Anyway, so that means X is a list. A is a set. So this one is a list. AB is a set. Okay. And A union B is so in this case the code, the output there is A union B. Also there is a common divisor and sorted for C. C is also C is uh, this one. Okay, this one is not ordered and sorted one. Then this will be sorted right down in increasing order. Then just the greatest one, maximum one, maximum and greatest. This is the greatest common divisor, and then the least common find out least common multiple this way. So what is the Python code to generate this kind of output there? And then the answer is this is the exam problem. The answer is this one. So you must memorize this one to uh, prove to solve our incoming midterm examination. So A is a set, A, B, X, Y is a set, A is 196, B is this one, M is the maximum of those two plus one. Then for N is range 1 to M, just repeat this one. So A A is if this is a set, then you use add, and this one is X is a list, then you must use append, okay, like this. So if this one, and then after that, just ask the computer to print out this one, then this will generate this kind of output. So just print out every this, and then using a mathematical operation. Now C is A and B. This is the uh, if this is a set A and B, then this is a common set. This is a common A and B, and what is D? D is A or B. A or B. So that is D is this one. So okay. So this is A union B. Oh, the common is A intersection B. So then the printout A union B is D. The common divisor set, common set is C. And sorted set is sorted C. And then the Python will sort it out and write down the element in increasing order. The greatest common divisor, max C is the maximum number of C. So C is in fact, well, C is a set because A and B are set. So C is also set. So C and D is a set, okay? And then least common multiple, then there is this kind of mathematical formula. Least common multiple is what? A times B divided by greatest common divisor. Okay. So max C is the greatest common divisor. This is the A times B. So when this one is divided by greatest common divisor, then you can get least common multiple. Okay, then please study this one. So this will be our examination problem for um, greatest common divisor and least common multiple. And then after that, homework 4, what is important in Pascal triangle. from these Pascal triangles. Also, this one is related to our final examination problem. So after the midterm examination, we will study Pascal triangles, so mathematical uh, structure for the Pascal triangle. The one of the most important thing is there is this kind of uh, summation structures. Okay, the hidden the triangular numbers and tetrahedral numbers are and Fibonacci problem. Lots of sequence are hidden inside of the Pascal triangle, tetrahedral number, something like that. So this will be our final examination problem. Okay, also because there is a kind of this kind of mathematical uh, uh, proof involved in Pascal triangle. So this will be our final examination. After the midterm examination, we will study this one. Before that, for this incoming midterm examination, we just study Python code to represent to represent triangular numbers and tetrahedral number in this way. Okay, so homework 4 is so write down Java code for the following output. So this is a Java code. I will give you this kind of thing. This is Java code. And then inside of this one, there is T6. This is a triangular number. And this one is tetrahedral number. Also, this one is a factorial function, to something like that. So this question is to write down a Java code to represent triangular number, tetrahedral number, and also the factorial numbers. So this is the output. Okay? And then the answer is, so you must study this code, Java code. Java code. So the first one is the uh, also in fact this is a factorial function. Okay, so this one is a factorial. So you may use factorial function. I just use f. So this is a factorial function, and this is triangular number. Triangular number takes something like that. And what it did, this is tetrahedral number. So study uh, uh, those Java code, okay, to Java code to generate this kind of uh, output. So this is our midterm examination for this Pascal triangle. Also, there will be one problem from homework 5. Homework 5 is related to rewriting system. So using this rewriting system, we want to study Fibonacci problem. Okay, Fibonacci. So there are two possible methods to calculate Fibonacci sequence, Fibonacci numbers. Also, the Fibonacci numbers can be found inside of the Pascal triangle. This kind of thing sequence satisfying this condition is called Fibonacci sequence. The proof for Fibonacci sequence, this one will be our final examination. So I want to emphasize the relationship between midterm examination and final examination. In our midterm examination, we want to we pay attention to just the coding structure of the content of discrete mathematics. But in the final examination, we'll pay attention to the mathematical structure. Okay, so proof for Fibonacci sequence will be uh, our final examination problem. This is a very important uh, ideas. So there's lots of important. This one is related to statistic probability, and lots of other areas. So, and this is called the generating function. Okay, so we will study this one in our finite generating function. And anyway, this one is important. So, so let's just look at the incoming midterm examination problem. Okay. So there are two possible methods. One is using the recursion function. Okay, so you must study both of them. Okay? So using this kind of thing, we want to find out Fibonacci sequence of seven steps. Then this one say that is 13. 13 is Fibonacci sequence at seven steps. So using this kind of uh, recursion code, you can find out the answer. The other one is a Lindenmayer system, rewriting system, and okay. So homework 5. Let's see. Let's find out 7. Okay, 7. There is a Fibonacci sequence at step 7. Then the problem is write a Python code to generate the following output. So this is the Python output, and this one is related to the Fibonacci sequence. Fibonacci sequence F0 is 0, F1 is 1, F2 is 1. Now we are interested in the value at step 7. Okay, step 7 is 13. And then using Lindenmayer rewriting system, just write down the situation in symbols like this. So A is adult baby couple, and B is a baby rabbit couple. Okay. So if you count A and count B altogether, then you can say there is 13 alphabet. Okay. Number of baby rabbit is there is 5. So you can count the number of A and B, then and the sum of those two can be a Fibonacci sequence number. So this one was our quiz problem. So I think you already memorized this one. So memorize this one again to prepare our examination. At the last step, we just count. Okay, we just count the number of letter A and B. Okay, let's go to next one. Finally, this is finally homework 6. Also, there will be one examination, one problem from this homework 6. Homework 6, we are interested in Sierpinski triangle. Sierpinski triangle is also can be explored using Sierpinski triangle. So the Pascal triangle. Once again, I want to emphasize one more. Pascal triangle. Inside of Pascal triangle, there are a lot of mathematical structure. The Sierpinski triangle, Fibonacci sequence, triangular numbers, and tetrahedral number. That's the reason why we study Pascal triangle in not only in discrete mathematics but also in computer science. The discrete, because this is a very good playground to write down a Python code, Java code also. There are a lot of important mathematical proof, mathematical logic. So it's a very good place to study both mathematics and computers. So the last problem is to draw Sierpinski triangle. The Sierpinski triangle, also there are two possible methods. As usual, recursion. Recursion is a very powerful methodology. So you can do a lot of things using recursion. So you can draw the Sierpinski triangles using this is the Sierpinski triangle. Like this is through this triangle. Now the turtle drew Sierpinski triangle using Lindenmayer system, rewriting system. Okay, this is the axiom, and this is the rule. There is only one rules. There is only one rule. So if you have a line, this is the line, and this line is divided in two parts. So this line, okay. So this one will be uh, after that. This one will be replaced by this one. So this one is S like this. Okay. So this left one, this is the angle. Then this is a total 120. Then this number, this left, this is left turn the by 120 degree. Okay, so this one given information that this one will equal to left turn 120 degree like this. Okay, then how to draw this kind of thing in terms of recursion code, Python code. So that's homework 6 is memorize recursion code and else Lindenmayer system code for Sierpinski triangle. This may be exam problem. So in short, write Sierpinski and draw function. Sierpinski, so this is an example. The draw function draws this kind of rules. Okay. Then the definition to draw function draw this Lindenmayer system rules. And then this one is, if step is 0, then just forward the length. The draw function is two variable, step and length. If the else, then this one draw this kind of thing. Okay, this kind of thing. So through this is m step minus 1, and length is one half. So originally this length is L, but now go to half of this one. And left turn, this is 120 degree, left turn. There is another line. And then now total is there. Then this one must return to the original position. Okay, original position. So forward minus 150. Sorry, then if this one, if total is there, forward minus number is just backward. This is the backward walking. Okay, just move in minus 100 in 150 distance. So that means just backward. Okay, so after this one, total will be like this. Okay, just backward. And then now we must rotate the heading position by 120 degrees, so that the heading direction is toward to east direction. Okay, this is east direction. So the right turn 120. So this is the right turn 120 like this. And there is one more draw function. Okay, draw step minus 1. Yeah. Okay, so as you see this one, so this is a structure. There is one. So draw function, draw this kind of one. Now the Sierpinski triangle is there are three. This is triangle, this one and this one. So there must be draw function for this one, and the second one, this one, third one, this one. Okay. So draw this one, and left turn 120. Draw this one, also left turn 120. Draw this one and this one. So by combining those three draw function, you can get a Sierpinski triangle. Okay. So color red and color black, by inserting this kind of coloring code, then you can visualize the structure. Visualize the structure like this, okay? As you see from this one, there's the blue part and red part and black part. So you can get an intuitive understanding for this kind of draw and sear, SIER, Python code. And then Lindenmeyer code is just the action is this one, and rule is S, S is replaced by this one, and the degree is 120, and go to a shootable place. After that, this is a length and this is a step. So steps 3 and of length 31, then you get this kind of uh, symmetrical triangle. Okay, so I just introduced uh, the four examination problem, but also I already uh, give you the first problem. What was our first problem? There will be 5 or 6 problem. And then from this video, I already give you four problem, and the one I want to add one more. That is a turtle trip theorem related to this one. And okay, this may be this will be our midterm examination. So this one is I want to know forward 150 and left turn 170. Rotate is left turn. Uh, I want to emphasize one more. In mathematics, rotation is always the positive direction. This way. Okay, this is a counterclockwise. So rotate means left turn. Okay, in mathematics, left turn is a positive rotation direction. Okay, total direction. So inside of the for statement, there is if command. So the turning degree, this is the turning degree, and total turn is 170 times n. Okay, this is total turn. When for n, if this one is divided by 360, the remainder 0, then the uh, total trip theorem means if the total turning is divided by 360, then the total return to the original position and original heading. That's the total trip theorem. Okay, so when this one is n, just print number n and break. Break means just break this for execution. Okay, for execution. Then you can check now the total return to the original position. Okay, so execute this one. Okay, this one, and then the number is 36. Sorry. So we can see that if you forward 150 and left turn 170, if you repeat this 36 times, then the total return to the original starting position and heading. Okay. How do you know? So this is the mathematical theorem. That is very interesting one related to mathematics and computer science. But okay, this is the total trip theorem. Okay. And the least common multiple this one, then this one return to the origin. So this is the first problem in our midterm examination. Anyway, I already present all the possible examination problems. So you must study those problems to get good scores and to good exams grade. Okay? Thank you very much, and study hard to prepare the tomorrow's examination. Thank you.